Alright, got a new project on the go here now today. This is a Flywheel off a Cat 3204 engine out of a Cat 910 loader, 1984 I think it is, somewhere around there, mid 80s anyway, early 80s. And being typical 3204, the engine quit. The rod went out through the side of the block. 3204s are not the easiest engine to find, so what my buddy's doing is we convinced him to put a 4BT Cummins in there, which is a good engine, obviously. Only problem is getting the 4BT onto the Caterpillar to drive the torque converter in the flywheel. I don't know if you can see it here. Got an internal gear basically, and it's not separable from the flywheel like we originally thought when we were first brainstorming it. We figured unbolt this ring, bolt it onto the Cat flywheel, do the bell housing adapter, or modify the bell housing. You'll see that later. It's the same size bell housing, but the Cat has a oil return port in it that I'm going to have to weld the machine in as well, so you'll be seeing that later. So best thing we can come up with, take this Cat flywheel, make it fit onto the 4BT Cummins, and to do that I've already machined a little bit off here. I started, never thought about the video, but basically what I got to do is make the back of this Cat flywheel look like this here. That fits Cummins. Normally it goes between the flex plate like this. Well, that's transmission side here, but it goes between the flex plate and the flywheel, and it's basically a spacer that got the pilot. What are you doing, Doc? That's the pilot there, and that's your ring gear. So I gotta make this look like that, which is not too bad. There's enough meat in the flywheel. I gotta take off a total of 413 thou from this face here to match this one, and then this register here is 150 thou high. So I'll do that, and then I'll transfer this bolt pattern in between these holes here, because these don't line up. I didn't measure it, but it's about 1/8 of an inch too far in. So that's that. The other issue is the ring gear for the flywheel. The Cat ring gear, the diametral pitch on the gear is way bigger than what the Cummins got. The Cat starter does fit into the Cummins bell housing, flywheel housing, whatever you want to call it, but in order to get it in there where the Cat starter is so long, you would have to bolt it into the flywheel housing and then bolt that to the engine. So if you ever had to change the starter, you'd have to remove the engine from the machine, and then you'd have to remove the flywheel housing just to change the starter. And of course, no one wants to do that. So we tried to get a smaller starter, couldn't find a smaller starter, couldn't get a Cat or a Cummins ring gear to fit this flywheel, because the Cat ring gear had a lot of meat in it, and the Cummins ring gears are much like this one. They're really thin, so there's no real way, easy way of getting it on there. So what we're going to do, or what I'm going to do, is when he gets at it, I'm going to lay this down there. I'm going to cut this center out of this flex plate for an automatic, and I'm going to machine a register into here and transfer the bolt pattern for the normally the torque converter into this flywheel, and we're going to bolt the ring gear onto this flywheel, which is a bit of a going on, but it's the only way really that we can see to go about it. So that's what's going to happen. We're using the parts on hand, trying to do this as semi cheaply as possible, not being super cheap, but no point in wasting money when you don't got to. So that's what I got going on. So I'll shut up now and start machining, and I'll show you a bit of that. Wondering why I'm not cutting in instead of going back and forth. When I cut on the inwards way, all the chips are flying at me instead of in here into the chip pan, so it's just a matter of not making a mess. That's 263 thou off now. That's as far as I'm going to go for the whole diameter. From now on, the next 150, gotta make sure that it only goes in the same diameter as whatever this here hole is. I gotta measure that and figure out what's on the go there. But it's cutting good. It's making a mess, but it's cutting good otherwise. Excessive on the measuring here, but this is something I really don't want to fuck up. Pretty much taking what I'm telling it to. Tell brighter than 90. That math is correct on 19 and we're at 90. So we gotta take I got 29 thou. Pump that or not. Anyways. 40. Perfect. Right where I wanted it. Right on the money. There we go. Now, hopefully, that'll fit on the same place that did. Transfer the bolt pattern, and that's pretty much it now for the crankshaft part of this whole conversion. Alright, getting ready to put this ring gear on now. I measured from this face here, that's usually, unless you're a crankshaft face, I measure from there to the back side or front side of the flex plate, however you want to look at it, and got that measurement. I'm comparing it to the face I just machined in here to here. In order to get that so the ring gear is at the correct depth on the flywheel, I got to remove 95 thou off of this. And before I can measure it, or before I can machine that, I got to cut the center out of that flex plate over there. Once I cut the center out and get my internal dimension, then I can turn this to match it. And I'm gonna cut the center out using the mill. I'm probably gonna have to remove the vise and the 3-jaw chuck for that. So I'm gonna clamp that down the table and probably put a boring bar in and cut the center out that way, because I don't want to remove this from the lathe until everything is done. I like to keep everything running true with the face that runs on the crankshaft, just because it is running pretty true in the chuck here now. I probably could get it straight again, but you know, why make things harder? Plus, I'm not sure if that flex plate will even fit in here that well. It'd probably be a pain in the ass to cut the center out. I think it'd be easier to do on the mill anyway, so that's what I'm gonna do. I got it indicated in as best I can. The hole is not exactly concentric, but it's averaging out to within a thou or two. That's plenty good enough for ring gear. Can't be that critical anyway, because this is just a folded over edge, and on the back side here it's actually welded. So I mean, I wouldn't imagine that they were too worried about a couple thousands when they done that procedure. So I'm calling this good enough. So I'll figure out a boring bar now, and then I'll be back. Alright, here's what I got going on. 3/4 inch boring bar in the head with a piece of high speed steel ground into a parting tool type setup. So I did a scratch. It's around 11 and 100 somewhere around there. Which I'm happy with. There's lots of meat between the bolt hole and the edge there. More than enough, really. So I think that's what I'm going to go with. Come on, get it. Come on, boy. Whoa. Wheel of death. Okay, I'm going to take 95 thou off of this, which is 2.41 millimeters. The reason why I'm saying millimeters, everything on this lathe for all the dials is in metric. So I got the carriage locked, so I'm not dragging shit across the ways. I'm going to pull that 9 here. 0, however you want to look at it. And I'll be doing all my feeding with this. So, like I said now, 241 millimeters in, and I'm going to get a diameter of 11 and 155. So, I'm going to double check that measurement now and write it down so I don't forget it, screw something up. Because it's hard to put metal back on, especially with cast iron. I don't really want to do that. So, I'm going to measure that now. Okay, 155. I should just convert that to millimeters and work with that. It's easier. So, 283.34 millimeters. What that gotta be. Let's see what we can do. And then I'm at 155 RPM. I'll try that. It's too much. Slow it down. Dial apart, clean it up. Really fucking stiff. When I got this machine, every dial was blacked up solid. Came from the college as far as I know, so I guess they didn't like setting zeros. Stiff spot right there, touch. So 295. $5 millimeter. Another 5 millimeters should bring me to 290. And I'll leave it there. I get most of the depth on, and I'll take the last 7 millimeters after. That should be 290. Oh. Yeah. 291 and change. It's close enough now. Oh. Start roughing it out. Five. Total 2.41. Good surface finish, though. I like it. If you hear this weird buzzing sound on the lathe, for some reason the brake band moves around a bit, and every now and then it rubs the pulley on the motor and makes that weird sound. I've messed with it, but it always comes back. That whole damn time. What I done then was give it a undercut to make up for the radius on the tip of the tool. Just to measure that. There. Nothing else to do, I don't think. Oh, that. Grab it in her. There you have it. That's the fit that I wanted. So you can slides on, but what's on there is good. So as long as that fits onto the crankshaft and the starter actually works, that means I done my job right. Now it's time to drill some holes. All kinds of holes. And great. The body of the tap is bigger than the fucking thread size. And now it's stuck. Put on that. Irwin. Fuck you, Irwin. You make good taps, but that's kind of stupid, that is. Tap an iron like this, there's no point to go backwards, break your trips. They break anyway. Just hammer in till the bottom's out. And stop then so you don't break your tap off. I didn't even look to see if all the holes lined up. You should. Oh yeah. I don't know if you guys can see it or not. Well, I'm going to do that 5 more times. Alright, those are all drilled and tapped. Well, tapped. You see me drill them. Now we got to drill the holes for the crankshaft. And I took that adapter last night. Battery went dead on this video fucking machine. So you didn't see that, but that now matches the back of a Cummins crankshaft. So fits in there, and the nice thing now is any Cummins flywheels I got turned, stick that shock bolt flywheel onto it, and I can do whatever the hell I want to do. As you can see, they don't quite line up. So we're going to put it right in the center and come in and pop some holes in it. And then that's pretty much done for this flywheel. Then we got a debacle of finishing the bell housing, flywheel housing, whatever you want to call it. Alright, got everything clamped in. I marked the center of the holes in the flywheel, matched them up with the holes in the spacer plate. Now it's my drill template. I got a stud down to the center, keep this all tight. And I got one little toe clamp on the edge just because it was there, and now it's not time to have something go fucking off on me, even though I don't think it will, but like I said, it was there, this is what I use it. I suppose you can see, yeah, you can see. Alright, here goes nothing. Clean this up and we're done. Everything lines up. All those line up. So there you have it. Cummins flywheel now. Well, text my buddy, tell him that's done. And I'll either bring it over to him or he'll come get it and drop off the 2 bell housings and start at that. I think that'll be fun though. Lots of aluminum welding in that.